So the first thing we need to do is to define a catalyst, and that is straight off your list of definitions, and it is a substance that alters the rate of the reaction, but it is unchanged at the end of the reaction. It doesn't never change, it's just unchanged at the end of the reaction. Fully explained by referring to collision theory, how a catalyst increases the rate of the reaction. So this has got a how in it, which means that you need to go into a bit more detail. The way the catalyst works is by orientating the atoms in the right direction and by doing that we land up lowering activation energy. Because it's easier to collide. I think you can do a little because easier to collide. They give you the decomposition of hydrogen peroxide into water and oxygen, and we say it's very slow, but it can be catalyzed, and they are asked to investigate 3 different catalysts. They're asked to rank the catalysts in terms of how quickly they bring about the decomposition. So it's not which one's fastest and which one's slowest, it's which one's fastest as well as which one is slow. So write down a suitable investigative question. It has to be a question, and it has to consider the entire rank. So I went with what catalyst, and then I put the 3 in brackets, decomposes hydrogen peroxide fastest and slowest. And by saying that, I have also considered which one must be in the middle. There are other ways of doing it, but you do have to have considered all of those things when you were deciding on your investigative question. One of the students suggests that they need to repeat the experiment at least 3 times for each catalyst. Why is this important? So it is to check precision, because without a number of repeats you can't check precision. And if there's precision, therefore verify accuracy. And finally, that results in a fair test. So we've got these readings over here, and they're going to ask me to get the average of the manganese dioxide. So I add those 3 numbers together, and then I divide them by 3, and I show my working, and I'm going to land up with 5,13 seconds. Remember, you're asked to work to 2 decimal places in physical science, so you should go to 13, and you must say your seconds. Name the compound that's given there. Well, it's iron and it's oxide, but the ion is in the transition element, so it needs stock notation. 2 ions hold hands with 3 oxygens, so that's 6 hands altogether, and therefore it must be iron 3 oxide. Comment on the precision of the readings for lead oxide and how can this be corrected. Well, the first thing is that 2 of the readings are fine. So first and third are precise. Second must be rejected and experiment repeated. That's how you would deal with that. In another experiment during the decomposition of hydrogen peroxide, students measure the concentration of hydrogen peroxide every 200 seconds. The results are shown in this table. Calculate the average rate of consumption in moles per cubic decimeter per second of hydrogen peroxide in the first 400. It's an average, so you literally say for rate, it's how much does the concentration change divided by how much does the time change, and you're going to land up with change in conc over change in time, which is 0,0131 minus 0,0200 divided by 400 minus 0. And you land up with a negative answer. It's going to be negative 0,000017, or if you prefer, 1,7 times 10 to the negative 5. And the unit has been given to you. I didn't actually allocate a mark for that. And it's negative because the rate is actually decreasing. I wasn't overly strict on that, but I could have been, and they will be in a matric exam. Will the rate of decomposition at 600 be greater, less than, or equal to the rate that you've just calculated? Well, the reaction as it proceeds slows down, so it's going to be less than. Concentration is decreasing as the reaction proceeds, therefore lower rate. We've got some information. A precipitation reaction involves the formation of an insoluble solid from the reaction of two aqueous reactants. The addition of sodium chloride to silver nitrate, which are both colorless, produces a white precipitate. So that's your story over there. The rate is irreversible. The rate of this irreversible reaction can be measured by measuring an increase in the cloudiness or turbidity of the product of the solution using a digital calorimeter. This instrument compares the amount of light transmitted through the solution with the amount of light transmitted through a sample of pure solvent. In this experiment, the percentage of light transmitted through a sample of the reaction mixture was recorded every 20 seconds. The readings were performed with 4 different concentrations of silver nitrate in an attempt to determine the effect of changing concentration of silver nitrate on the reaction rate. So that's the aim. The results of the investigation are summarized in the following. So we are actually looking at a link between change of concentration and reaction rate. We do that by looking at turbidity levels. So let's see how the questions unfold. So we've given all of this information over here. We've got different concentrations. We're measuring the time every 20 seconds. Give a suitable hypothesis for this experiment. And the best hypothesis is greater concentration. And you need to write a full sentence if you're doing conclusions and hypotheses, because they're not just a link. They didn't say give me a link. They said give me a hypothesis. A hypothesis needs to be a statement. So the greater the concentration, sorry, I've run out of thing, of silver nitrate, the faster the reaction, because that's what we were trying to get a link between. What is the independent variable? So obviously we're changing the concentration. I'm changing that. The concentration of silver nitrate. What is the dependent variable? I was prepared to give you 2 things. One is the rate of the reaction, because that's ultimately what I'm trying to work out. But actually what we were measuring was the percentage of light transmitted. So I was willing to accept either. Give 2 variables that were controlled in the investigation. I had to keep a number of things the same, and it's not the equipment or anything like that. You're not going to get marks for that in an exam. Something like temperature or concentration of the sodium chloride, or volume of the silver nitrate, or volume of the sodium chloride, or all readings were taken at 20-second intervals. Not great, because that doesn't make your experiment work or not, but it does give it some consistency. So those are some of the things you could have put down. Don't tell me use the same calorimeter, or it must be in the same room, or something like that. That's far too general, and you're not in grade 8 anymore. You need to become more specific. And then it says, on the same system of axes, plot your results for the 0,5 mole per cubic decimeter and the 2 mole per cubic decimeter tests. What's important here is that you give your graph a heading, that you label your axes, you put units on them, and that you plot your points, and that you have even scales. So you land up with the graph that's got the heading. You must put 0 onto your graph. You then draw these two smooth curves through the points that you had, and you'll notice that the decrease goes faster with 2 molar solution than 0,5. Don't forget seconds on the time axis and even scaling along over here. You were then asked to decide when you had 70%, what was the time at which 70% concentration happened. So you go along on your graph, across and down. I got to about 125, some people got 120, and again across and down, and I got to about 37. There was obviously some room for variance over there. And now it asks you, after you've got that at 125, let's say, and you've got this at, let's say, 35, it asks you to determine the concentration, which you've got, divided by the time, which you've got. So you literally just take this number over here and divide it by that number over there, and you land up with 0,004, and you should, they didn't give a unit, but you get it later, so I didn't mark it very strictly, but that should really have the unit in the heading over there, and this is 0,057 moles per cubic decimeter cubed per second. Sure. What is the unit that should be used? We've just discussed that. If I'm taking moles per cubic decimeter and dividing it by seconds, I get mole per cubic decimeter per second. What do conditions need to be met, not are need to be met, for a reaction to occur according to collision theory? And it's about how they collide. It's the conditions, and they must collide with the correct orientation and more energy than activation energy. Explain your conclusion above. And that's this one over here. Oh, we didn't do the conclusion, so maybe we should do that. What conclusion can you draw from the tabulated values regarding the effect of concentration? Well, quite clearly we have got a faster rate of reaction when we have a greater concentration. And again, it's a conclusion, so you should write a full sentence. I'm just writing quickly, so it's faster rate for greater concentration, but you should have that as a full sentence. Explain that conclusion with reference to the behavior of the reacting particles, and it's worth 4 marks, so you're going to have to kind of do quite a lot of detail here, and the detail's not long, but you need to go through the steps. So there are more concentration means more particles. More effective collisions, and therefore faster rate. Students set up this experiment using the apparatus shown. They collect the carbon dioxide gas released during the reaction and measure the volume of the gas that they collect every half a minute. So it's an antacid tablet with hydrochloric acid. The results of the experiment have been given by the graph to show the volume of gas produced over a period of time. It might be nice if this graph had a 0 on it, but they don't. Notice that my time's in minutes. At what time did it reach completion? When did I get a flat line? I got a flat line at 5 minutes. How did the rate of the reaction change with time from 0 to 3? Well, the first thing is it starts off slowly because the particles need to come into contact with one another. So that part you need to say to me, it's getting faster as particles meet, something along those lines. And you need to say right at the beginning or between 0 and 0,3 seconds, something like 3 minutes or whatever. Then you can say the rate then goes quite fast and is steady up until approximately 1.5 minutes. So 0,3 to 1 minute, it's quite a constant rate. Then the concentration starts to decrease because we're using up the reactants. and it's the concentration of the HCl that's decreasing. Therefore, rate slows down. It was worth 5 marks, quite a lot of stuff to say. And here's your rate slowing down over here, up until 3 minutes. Then it says calculate the average rate of the reaction in centimeters cubed per second. You haven't got seconds, you've got minutes. So, and it asks that for the time period for the whole experiment. So it's an average for the whole experiment, beginning to end. So the first thing that you need to do is you need to say change in volume divided by change in time. And the change in volume, if you take a look, this isn't 35. This over here is 37. So you actually need to start being more accurate. I wasn't very strict, but I will be. So you're going to say 37 centimeters cubed, and the time when it finishes is going to be 5 minutes, which is 5 times 60 seconds, which is 300 seconds. And you land up with an answer of 0,12 centimeters cubed per second. The students carried out further experiments investigating the reaction of antacid tablets with excess hydrochloric acid, and the details are below. So you're always going to look for the anomalous piece of information here. That's the only one with a higher concentration. Here is the only one with a higher tablet, and here's the only one with a lower temperature. So this will be slower, this will be faster, and this will be faster because there is more surface area, and you will get more product. They say you've got excess hydrochloric acid, so there's plenty of HCl. So you will land up getting more product from the 2 tablets. So let's think about that. Which one lands up going faster? C lands up going faster, but you don't land up with any more product at the end of the day. So C must be, if I'm going faster, it must be number 3. Then you've got D, which goes faster and lands up with more product. So that must be number 2. And finally, A must be when it gets slower. So that is number 4, because that's slower than the original curve. We were told that graph B represents the first experiment. And you had to give reasons each time.